Well, hello everyone. I'm glad to have people in the room because this talk wasn't planned until early this morning. Because, you know, there's this very nice and awesome presenter named Bjorn had plane problems, and we had these talk slots to be made available like at the last minute. And I spoke with Mike and said, well, I can wing something for an hour, that's okay, but as long as you like slides in the time that I have, because I want to go to the keynote, you know. And he says, well, fine, let's do this. So, my friends, we're going to go through this live coding through and through. So I don't even have a presentation slide, but if you're curious to know about me, and don't, this is me. And you can write to me, whoops, should my keyboard decide to work. That's going to be fun for live coding. Cool. And if you want to write to me, well, the easiest way probably is Gmail. And I also have another one with my email from work. You can go in the other door if you want. But please come, that's fine. Cool, yeah. So since the thing wasn't advertised at all, welcome. Hello. This was as much a surprise to me as it is to you, but still I think we're going to have fun. So trying to figure out what I could do to make something amusing for an hour or so. Well, I told Mike, well, these are warm days. I was hearing what's going on in London this week and all. And I just did a class for the last 2 days on generic programming with very nice people. And there's something we did that I thought might amuse other people. So I thought maybe I can extract that thing and make that into a small 1 hour class on something amusing, tied to the weather, why not? So, and tied to my own experience. So I wrote incredibly bad code there. So it starts with that using the necessity that's going to stay there because I'm too lazy to do local usings in the stock. And I wrote a macro because sometimes you do that. Because where I used to work at CA Electronics before I became a professor like 25 years ago or so. We did flight sims, and we did them in C and Fortran. And we had this big header file filled with conversion macros like that all the time. The point being that it was a central point for those functions, and we did a number of types of conversions because we were using metric units, imperial units, and things on spherical surfaces and stuff. And that was the kind of file that you weren't allowed to modify because you had to rebuild the whole flight sim if you did, because everyone depended on it. And rebuilding a whole flight sim in the 90s, it was 23 hours. It must be worse today. So 23 hours, you just locked the shop for the whole day. And the code in the main there is trying to express a conversion from Fahrenheit to Celsius. Now, if you're too young to remember about Fahrenheit and you're living in Canada, it's a measurement unit that they use in the US still. And that thing, the computation, I think, is proper or correct in the macro. It's a macro, so you need to be careful, but this one is a bit easy. I should put parens around the X to be really, really correct, because that thing has to be evaluated, and my machine is scary this morning. I don't like it when it does that. It's been doing that to me for hours now. I think the antivirus has decided to start on its own this morning for some reason, and I don't control it. Please collaborate. So yeah, to ensure that the side effects are contained. So this thing should display that 41 Fahrenheit is 5 Celsius, because I think that's the proper answer. It's going to look kind of like this, okay? And let's hope it works. Now, the thing is, we used to do things like that, and it's really, really bad. It's terrible. Did you like this kind of code? Because some people are moving their heads sideways like that. It's terrible code because there's no safety anywhere in it. You see doubles. So you have to remember from the names of your variables what you were trying to do in the first place. And it's so easy to make mistakes, and costly mistakes at that. Hello there. Costly mistakes at that, because you could be trying to send a shuttle somewhere and using the wrong measurement unit, send it to some other place, and it's going to cost you a fortune. Or it's going to kill people accessorily. There are things like that that happen that you don't like. It's still compiling. This is ridiculous. So it's going to be a fun live coding experience. So what I think we should strive to do is to have stronger measurement units in this case, such that when you're writing code, instead of using doubles, you're using Fahrenheit or Celsius or such things. And we're going to try to get there with, I hope, proper code is trying to deactivate something. It's got 5 Celsius. Took forever, but still. C++ is fast. It's something else. Yeah. Deactivate. I don't care. So let's try to turn that code into something that's nicer, if hopefully my mouse will collaborate. So I would like to get rid of this and end up with something like the following, but it won't compile right away, of course, because it's too early in the talk. So something like a temperature, whoops, let's start with this. Auto Fahrenheit, something like this, yeah? I'm going to be writing literals, okay? And if there's an equal sign, it's even better, like this. So let's suppose this means 41 Fahrenheit, okay? And let's suppose I want to do a Fahrenheit to Celsius conversion. I'd like to get to something like this, kind of. Temperature, whoops, yeah, please. Celsius or something like that. Celsius equals Fahrenheit. And ideally, this would produce, or this would provoke the conversion in a safe manner such that there's no way I can mess up. It's kind of neat. But we have to achieve that without loss of performance, because otherwise, you know what's going to happen? People will write shitty code instead. So we want the code to be proper, correct, and fast. Okay? And we'd also like something like this to display 5 Celsius, because that's what it's supposed to be. Is that fine? Do you prefer this sort of code to the one I used to have? That's my dear hope, because this is what we want to get to, okay? So what I'm proposing at the talk today is we're going to get from here to there, okay? Using a number of techniques, and at any time, you don't need to keep your questions for the end of the talk. Raise your hand and speak loud if you have a question. I'm going to repeat it quite simply, and we're going to introduce that or induce that into the recording. And I'm going to keep this because I'm not good at remembering formulas, so I'm going to get rid of it at some point. Okay, so the way we're going to do this, I have a temperature class now. I'm going to have only one. The point for this is going to be that I'm going to be changing the way this class behaves, hello there, based on some other classes. And I'm going to be using traits to achieve my goal, which are a fun technique that you can use to do some cool things at compile time. Since temperature units, they look to me like some fundamental building blocks, I'm going to make sure it's a context expert class so that I can use it in compile time and check my stuff with static assert. Is that okay? Cool. And I could push it quite a bit, but we only have an hour or so to do stuff, so this is what we're going to do. So follow me and ask questions whenever you want. First thing I'm going to do, I'm going to use 3 measurement units. I know there's more than that, but they're the 3 I remember easily. I found a weird one in XKCD at some point, but I forgot what it was. So I'm going to have Celsius, like this. It's an empty class. I love empty classes. I love them. I don't know about you. I know my Java friends find that creepy that you can actually do stuff with empty classes, but I think there's more empty classes than non-empty classes in my code. They're awesome. I'm going to use Fahrenheit, which is a weird thing to spell. So I'm going to try to spell it properly and use code completion afterwards because I tend to mess it up. There's too many H's in there. And I'm going to use Kelvin. And I'm going to hope that there's no physicists in the room because I know that the physicists, they use Kelvins with a high precision and they put a number of decimals after 273. And I don't because I don't remember them. So these will be my measurement units. Fine so far? Cool. I'm going to write traits. Now, traits are a technique by which you document types outside of the types. They're a non-intrusive technique that lets you extend your code easily. It's kind of nice. It's not strictly speaking necessary here, but it's fun to show. We use that a lot in the standard library. We use that for cars. We use that for... There's a long list of type traits, really. So I'm going to write traits for each of them to specify some particularities of each of these measurement units. In this example, there will be 4. So I'm going to be using a name, like C for Celsius, and F for Fahrenheit, and K for Kelvin. I'm going to give myself kind of a baseline for a default value. It's going to be 0 for Celsius, and I'm going to get the equivalent for Fahrenheit and Kelvin. So with Fahrenheit, if you look at the equation on line 8, in this case, it's going to be 32. Because from memory, 32 Fahrenheit is 0 Celsius is the temperature at which water freezes on Earth, kind of. Okay? And Celsius, Kelvins, I'm going to use 273. I think it's 273.15, but you know, make it simple. The other 2 things I'm going to put in there are 2 functions. One of them is going to call to neutral, and the other one is going to be called from neutral. Why is that? Because if you have a number of measurement units and you try to make single conversions in between every composition that you can make, you're going to end up with a ton of functions. And I'm just not going to do it. Okay? So having a single neutral, I'm going to take Celsius because it's the standard unit for most of the world, at least. And my two neutral is going to project the temperature into Celsius, and the from neutral is going to take it from Celsius to something else. So sometimes, many of them will be no-ops. Who cares? Okay, because the point is to let the compiler generate good code. In this case, it's going to be as good as the macros, if not better. Is that okay? So let's start with Celsius because it's the easy way to do things. So since I don't want the traits to exist for non-temperature stuff, I'm going to write an incomplete class to start with. It's going to be called temperature traits because it kind of looks like what we do in the standard. Incomplete. So that means if someone says temperature traits of string, unless someone weird went behind my back and added it for me, and that person is not my friend, it's not going to compile. And I'm going then to specify those traits for the three measurement units I'm caring about. So I'm going to say, well, technically speaking, we're not supposed to be requiring those empty pair of angle brackets anymore, but my compiler, as far as I know, requires it still. My compilers, I use me. I'm going to specify, please. I like antiviruses, but not when I'm giving talks. Celsius, please collaborate. There we go. So my first case will be, what do I do with Celsius? Do you mind if I use string view? Are you okay with string views? I really like them, especially for constants, okay? So I'm going to include string view and use this for my names because they're all compile time things. It's a C++ 17 feature. We don't really need that. I could be using const char stars. It would work, but let's make it nice. And so my name will be a string view. That's a string view literal. It's const explorable, no problem. I can use it at compile time. The nice thing about string views is that they provide you with the non-modifying, non-mutating functions of strings. So you have stuff, but it don't cost you more than char star. So it's awesome. I'm going to be using a constant for the threshold at which the water freezes. Static const expr. Yeah, of course, written properly is going to be better. Double say freezes at, for lack of a better name, this will be my Celsius thing. Okay? I know this is not technically proper for physicists. Let's make it look like it. And the to neutral and from neutral, but since this is my neutral representation unit, it's going to be a pass-through. So static const expr, double to neutral for some value, return the value. Should be no except and all, but let's keep it simple. And from neutral, same thing, because projecting from Celsius to Celsius doesn't do much. So far, so good. Are there any questions so far? Yep.
Yes. Why static and const expr at the same time?
Because const expr does not mean static. Yeah. Static means belongs to the class. Const expr means can be resolved at compile time. Other questions? It's not necessarily compile time. It's compile time if you ask for it. But I'm going to do so why not? We're going to do the same thing or similar with the other two if I get my mouse back, and I just did. I'm going to copy and paste because we have only that much time. Fahrenheit. I'm going to need your help for some of the equations because I'm bad. So F for Fahrenheit, freezes that, we agreed it was 32. And now we need to do some equations. So the to neutral is Fahrenheit to Celsius. It's pretty much what we have there. Hello. So let's go with this. It's going to be val and not x. So val minus freezes at something like this. Does this look like an appropriate computation? If you're saying you don't need that paren anymore because you're not in the macro, yes, I agree with you. So this should be pretty much what we expect, with a space there to make it look good. And the from neutral should be Now, watch me because I might be making mistakes and correct me if I am. The reverse of that thing. So something like val times 9 divided by 5 plus that freezes that thing, which I think is the reverse of the first one. Am I mistaken? Pretty much. Okay, cool. So we have 2. Now let's do that Kelvin thing, which shouldn't be too hard, but I always mess it up for some reason. So Kelvin, it's going to be K's. K's like this. Let's suppose it's 273. Kinda. And one of them is plus and the other one is minus. I always mess that up. So Kelvin, 2 Celsius, is it plus or less 273? Plus. So if we make a mistake, we'll just correct it, okay? So if this is 1, the other is the reverse. Is the reverse? You're the boss. If we made a mistake, we'll fix it. Okay? So the important thing is that we have a function for that. Questions so far? So yeah, I just proved that I'm not a physicist. Physicists are spot on this. I'm not. Okay, so if I messed it up, correct me. Now that we have this, what is the temperature class going to be like? Let's go for that. So we want a single template in this case that takes as argument or as template parameter, the thing on the template line, the kind of referential unit we are planning to use. One of these 3 properly, but it could be something else, as long as it implements those traits. So if you find out a new way to measure temperature at some point, which could happen, it's happened in the past, it's easy to fix, and you still have your class. Okay? I'm going to strive for something that behaves kind of like a literal to make it usable in efficient code. That's the goal there. So template class. I'm going to be using R, if you don't mind, for referential. Okay? Class temperature. With an E there. So far, so good. So there's no such thing as a temperature class, but there are many temperature R classes for various types of R in this case. Now we need to make design decisions. So I use double for my representation of the value so far. I'm going to keep doing that. We might do a better job. We could be letting the traits specify the type to use with an alias, like using value type or something. I didn't do this just because of time concerns. We don't have much time to go through all of this. So let's suppose we could do a better job, but I'm going to stick with double in this case. So the value for my temperature is going to be a double. Now, I need to pick a default value because that's interesting to have a default value for temperature. And some people would say, put 0. But I would claim that in this case, 0 is fine for Celsius, but it might not be fine for the others. Because if we're striving for something that's more cohesive, it might be easier to have the default value for each of the temperatures to be equivalent to the other. So I'm going to go for the temperature at which water freezes in each case, which might give me a non-zero default value. If you disagree with me, that's fine, but this is what I'm going to do with this case. Now, to infer that thing in my code, I'm going to extract the freezes at information from the traits of R. It's a constant, so the way to do this is going to be temperature traits of R. Freezes at. So depending on R, I'm going to have different values there, but that's fine for the plan I have so far. Are there questions? Cool. Okay. So I suggest that we can easily... You have a question, my friend?
Yeah. Do we need to put public or
I'm getting there. Well, for a class, you put public when you want public stuff. It's private by default. For a struct, you have public by default, and you can switch to private if you feel like it. But this one is going to be like this. Yeah, so a default temperature will be at the temperature level that I want it to be in this case, 0 for Celsius and 32 for Fahrenheit. The nice thing about the equals default in this case is that I'm getting const_expr for free. Because my initial value is known at compile time, and if you put equals default and your data members are const_exprable, you just roll the const_expr constructor that does nothing, but can do nothing at compile time, which is totally awesome. Doing nothing is good. Doing nothing at compile time is better. Now, Jason would be so proud, Jason Turner. Now, if we want people to be able to know the actual value we stored in there somewhere, it's kind of useful to offer an accessor function to get it. So one way to do this would be to have a constexpr double value function that returns the value. It should be no except and all. I'm just going fast. There. Questions about this? So that doesn't mean you will get the value at compile time. It means if you constructed the temperature at compile time and during a constexpr context are asking for the value, I can actually give it to you. I'm able to do that. So I could be creating at compile time a table of the temperatures for the day and setting everything up, and it would be doable with this class so far. I don't have to write the copy constructor, the copy assignment, and the destructor because I have no data from which or for which in my class I'm responsible manually. So I'm going to put these aside. What I do need to have, though, that's going to be very important is a conversion constructor. So a constructor for a temperature of R that takes a temperature of something else because I want to be able to create a temperature in Celsius from a temperature in Fahrenheit, say, and I want the conversion to kick in. So I'm going to need to write that. Before I go there, though, I'm going to write a constructor that actually just takes a value because it's cool to say, well, this is 41 Fahrenheit or something. So this is not a complicated one. I could be doing some validation. I won't. But I could be saying, no, you cannot go below absolute zero. But I'm not going to go there. Temperature with some initial value there. So I'm going to believe my client that's giving me this value and say, I'm sure it makes sense. So this way, so far, I'm going to be able to, I could write there temperature in Fahrenheit equals 41, it would work. It doesn't work now because of that weird syntax I use at the right side of the assignment. Well, the assignment symbol, because it's not an assignment. So far, so good? Now, okay, I had COVID a few weeks back, and I'm still damaged a bit. So now that we're there, I'm not contagious, I'm just keeping myself healthy. Now, the conversion constructor. I want a constructor that's a template that's going to take a temperature of some other type than R and convert it for me. That means I'm going to have to perform a conversion of the value of a temperature expressed in some type T to the reference system that I'm using for R. Before I code this, it could be cool to have some kind of temperature cast that casts from a value to another value, going from the initial value to the neutral system and from the neutral system to the new system. So if you don't mind, we're going to get outside of the class for a moment and write this kind of cast thing. Is that okay? Cast-ish. So something that takes a destination referent and a source referent. So far, so good. So Celsius, Fahrenheit, or something like that. Constexpr from double to double. Constexpr, yes. Double or auto. Temperature cast that takes a double as source. Let's see. So we want that thing to be at least as efficient as the macro, but without the problems. Okay, so someone trying to convert from Kelvin to Celsius will use Kelvin as source and Celsius as destination, but we're still playing with doubles. We're just building the conversion to the machinery of the type system. It's an easy trick. It's a one-liner, but it's a complicated one, meaning that I'm going to take val, push it to neutral, and then take the result and take it from neutral to the new system. So something like return. The endpoint is from neutral, from the reference system of D. So temperature traits of D from neutral of temperature traits of source to neutral of the source. And that's it. So this is all totally doable at compile time. You have a question? Okay, cool. So I'm taking one, pushing to neutral, taking it out. If it's to no up, it's perfect. This kind of code is highly inlineable. I don't worry about function calls. They're going to go away. Cool. Constexpr, that's fine. Now that we have this, we have a way to convert from value to value. Let's write the conversion constructor that we're missing. It's going to look kind of like this. So template. T, because I already use R, so let's take T, temperature, I guess, or whatever, doesn't matter. Const expr, temperature. That takes a const temperature of T. Now, T is not R, it's important, because R would kick in the, make the copy constructor kick in, and that one works for me, and just copying the values, I'm doing that. Unplug the phone, you're bothering me. So there. So the goal is to initialize the value properly. You know? Good const expr constructors, that's what they do. They initialize their data members, and that's pretty much it. So my value will be a temperature cast from, well, to R from T of the value of the other, like this. And that's pretty much it. Are there any questions so far? It's almost working already. Okay. One thing that could be cool, well, if we just want to see if the basic working is effectively there, we could just make a temperature and display it or something. So let's try this. If we want to output a temperature on screen, make it simple. It's going to be something like this. Indeed. That takes an O stream to which we're going to write, say cout, and some temperature. Oh, if it's a temperature, I need temperature of what referential? So it's a template function. Template, class R, well, we're at it. So const temperature of R, like this. Temp, is that okay for temperature? It's not temporary, it's kind of a mess. So it's a simple thing, really. We want to output the value followed by the name of the unit. So something like return os temp.value followed by the unit. Now the unit is not within my class. It's within the traits in this case. So temperature traits of R name, and that's it. Really. If I did my job right, it should do something nice. So far, so good? Cool. So let's see if the basics work. Let's put this one aside for the moment. So temperature, like this, in Fahrenheit, far equals to 41. And if I did my job right, this should display 5 Celsius. It's a start. Let's see if it worked. Please do. It's kind of cool. So there is no conversion that I have to do by hand in my client code. The scaffolding does the job on its own because the things convert to one another seamlessly because it's built into the mechanics of my class. Are there any questions before I push further? We're still okay?
Let's say you try and put a string in there. Is it a compile?
It won't compile. It won't compile. Yeah, because there's no way to do that. I don't have any constructors to do this, which is pretty much what I want. Okay. I'm totally fine with compile time errors. They're much better than runtime errors because you can fix them at home. Okay, I don't have to fly somewhere weird to fix them. Still cool? Now it would be cool to replace line 72 with line 71. Could be a start. If you're not familiar with the user-defined literals, well, it's not going to be a primer. There's whole talks on that, but it might give you an idea what you can do with this. If you think that in your code, such concepts are deserving of being literals, because maybe you will say, no, that's not the case. It really depends on what you're doing. Okay? This is a safety feature, really. I like literals that have strong types. I like them. It brings, I think, more meaning to my code than just straight doubles where you don't know what the double represents. I know what the Fahrenheit represents. It's something from the old days. That is a joke for my American friends. So in this case, I'm going to write 2 versions of each of the operators, the UDLs that I'm interested, the user-defined literals, because in C++, if you want to take floating point values with your literals, you have to write a literal that takes a long double as argument. But if you want to spell it out as an integer, like 41 or something, and not 41.0 all the time, it won't find the floating point literals. So I'm going to have to write both the integer version and the floating point version in both cases, in all 3 cases. It's trivially easy to write in this case. And the good thing is that since my objects are const explorable, they can actually look like real compile time entities in my code if I'm so inclined. Okay? So let's try this. Let's start with the Celsius. It's the easy one. Temperature in Celsius. Operator. This is a user-defined literal. So this is the syntax we use. It's operator quote quote. It's a Canadian invention. It's Michael Wong. And then you have to put the suffix that you want to use. If you want to do a good job, you must prefix your suffix with an underscore. In the standard, we assume that the suffixes that do not start with an underscore, they are ours. So if you do that yourself, you're going to get in trouble. Some compilers actually enforce this. Okay? So I'm going to use uppercase F for Fahrenheit, uppercase C for Celsius, uppercase K for Kelvins, just because I think it reads well, but it's personal. So for the floating point thing, if you're doing UDLs like this, if you want floating points, you have to use the biggest floating point we have. It's long double. At worst, you just cast it in your code afterwards. If that's not what you're using, I'm using doubles in my code. I'm going to cast. If you're using integers, you have to use unsigned long long. So if you want to do a minus something, you have to write operator minus for your temperature class. Is that okay? Because the literal will be unsigned. So let's start with the long double thing. Long double. Wow. It's really easy because I have a constructor of temperature Celsius that takes a floating point number. So it's going to be return. And I could just write it this way. It could be easy. But if I do this, I'm going to get a warning because I'm trying to store a long double in a double, and that's a narrowing conversion. Then I'm using braces, and it's going to complain. So let's cast it to double. Is that correct code? Are you fine with this? Yeah.
I'm not sure why we need to receive a long double.
It's because when you're writing literals, all literals that are floating points, they're all long doubles. And when you're writing integers, you don't have a choice. When you're writing integers, it's unsigned long long. It's the biggest one that you have. And if you want to do less, cast stuff. Yeah?
That's also something that makes it fairly difficult if you have like a templated temperature that has a variable scalar type. Then it gets really complicated with the defined literals. You would need suffixes if you want like floating point results, something like that. So it works if you have just a single type, but otherwise it's fairly complicated.
Yeah, it is. So if you want to do something more complex than just long doubles and unsigned integrals, it can get effectively airy. I suggest, if you're interested in the nitty-gritty details of this, Pablo Alpern had a good talk at CppCon last year where he went to a lot of detail into that. He wrote a number of them, including base 3 integer literals in many ways, okay? And this is just a primer, really. It's an hour talk just on that. It's a very good talk. So Pablo Halpern, I highly recommend that. I watched it this week because I was curious, I was tired. I had a lot of fun. Okay? I learned stuff. There were a few things in there I didn't know, and I know most of it. He worked on it, he wrote a book. So this will be my long double part, and the long integer part, the unsigned long long, will be similar. Well, because really that's it. I'm going to cast to double because on principle, but that's it. So now I can write 41 underscore C or 41.0 underscore C to get the same results. Cool. I'm going to do the same thing with the other two. As you can guess, it's pretty trivial at this point because I have almost nothing to change. So Fahrenheit, it's going to be an F. The fact that I didn't spell out the type in my return statement makes the code easier to maintain, as you can see. I don't have to change anything else than the return type of the function. It's kind of neat. Okay. So some people like to write more code. If you write more code, you're going to maintain more code. And if I do the kelvins, as you can guess, it's going to be pretty easy. So kelvins with the K there and the K there. So at this point, normally, if we're doing something like this instead, we should still be getting 5 Celsius, and we could even print the first one. So Fahrenheit equals Celsius, and should give us 41F like this, if we did the job right. Kind of works. Yeah, neat. Okay, questions so far? Okay, the next step after that would be to be able to compare them. because it would be cool to verify in a static assert that this holds. But we did something mean there. We're using floating points. So if we want to use equal, it's going to get tricky slightly, although it will probably work in this case. Now, I gave a talk last year at CppCon, if you want to look at it, on how to do that. So I'm not going to redo my talk, but we're going to implement it. It's rather easy with concepts these days to have a close enough implementation that compares integrals or compares floating points properly. So if I want to write an operator equal in my temperature class that does the job, something like bool constexpr, bool operator like this. I could write spaceship, I won't go there this morning, with another temperature. Const. I think it would be fair to say that it will be okay if the two values are close enough. So something that return my value, well, close enough, my value with the other value. And we're going to write this thing. Is that okay? So I'm missing the function now. I could also write operator different from, but with C++ when you, we have that for free. Because if you write equal, you get different from out of the box. Okay? And if I wrote spaceship, we would have all 6 operators, but I'm not going to do that because time constraints. Is this okay? So we'd like to be able to check in a static assert that R2 are okay. So something like, let's make sure that 41 Fahrenheit is the same thing as 5 Celsius. To be cool. Yeah? But for that to work, of course, close enough has to work. Is that okay? Cool. So, now I hope it won't compile, because it shouldn't compile because I didn't write the function, and it's not complaining, which is, yeah, it's complaining. Cool, good thing. So how could we write a correct, close enough function? If I'm using concepts, it's going to be kind of cute. If you don't mind concepts, do you? No? We're in 2022, we're allowed to use concept these days? We could write it without concepts. If I write close enough, in 1998, it's a page of code with the number of techniques. If I write it in 2011, it's enable if, everyone's eyes will bleed. I'm really sorry. If I write it with 2017 code is going to be if constexpr, is going to be much nicer. But concepts are so cool, so why not use them? Sorry. So one way we could do this is to make, well, let's start with the easy case. Let's start with the integral case. So concepts, let me do something like this. Constexpr bool, because the close enough is going to be a Boolean thing. Close enough. And now if I want to be able to compare an int with a long, say, or a unsigned long with something else, short or something like that, and I'm open so to have mixed integral types with my equal there, because why not, really? With concepts, it's rather trivial. I'm going to be using an integral auto, A, and an integral auto, B, like this, and compare them. I think I saw a hand, don't worry. I think that for integers, that should be okay. So if you're not familiar with concepts, what this means is A has to satisfy the integral concept, it could be a short. B has to satisfy the integral concept, it could be an unsigned long, and the code will be generated for these two types. If you're worried and would prefer both types to be the same, you can write it differently, very slightly. You could say something like template, integral T, and use T there and T there. So if you do that, they're both going to be integrals of the same type. But I didn't see the point in this specific case. So is this okay for the integer case? Yeah. Integral, in this case, supports signed and unsigned. I think there's an unsigned integral concept, but you should check in concepts to make sure.
Yeah, I mean, to mix one unsigned and one signed.
Well, do you mind, if you compare 3 with 3UL, is it going to be okay with you? If you compare literal 3 with literal 3UL, which is unsigned long, you expect them to be equal?
Yeah.
That's okay. What's going to be messy if you do that, though? You have to be careful, because this is a very simplified example. If you want to compare -1 with 1u, you might have a promotion from -1 to a big number, but it will say they were not equal in the first place, so it's still going to be okay with this. But if you want to compare ordering, we have other functions like that, like CMP underscore something. There's a number of functions that do proper mixed signed arithmetic with integers in the standard. I don't have the header in my mind right now, but they do exist if you look for them. So if I was doing something that does ordering comparisons for integers, I would look into them, because you know the problem, eh? -1u less than 0 does not give what you think. Yeah, my friend?
Yeah, I was wanted to point out the same thing. Mixing signs is really dangerous here.
Yeah, but
if you have a really high temperature and a small negative one, it would compare equal. So in general, I would guess we should restrict it to have the same type, right?
We could, but with equal, it's not a problem, because if they're different, they're going to be different. But with ordering, I would be careful, though.
It's the same after the conversion. If you convert a negative number to a positive number, and the other one happens to have the same value.
How could it happen? For which value would it happen?
I don't know.
I don't think there's any value for which it works. If you have -1, you're going to end up with something that's bigger than the biggest signed integral you could have. And even if you have the minimal value, you're going to end up with something that's too big to fit into a signed integer. So I think with equal, you're okay. But with less than, you're not. With less than, I agree with you both. But that's not the one I'm quoting right now. If I code operator less than, it requires the carrier suggesting, definitely. Is that okay? If you find a case where it works, just write to me. I'm going to be glad to look at it. This is for the floating points. Other questions? Okay. We can do the same thing with floating points, supposing that we accept mixed floating points, so float with double or something, because we want the code to compile, in our case, when we have doubles. The concept is floating point. So floating point auto. Again, if you want the same type, you can force it. Floating point auto. Now, warning, the code I'm going to write is slightly incorrect, but it's a matter of time, okay? So the kind of easy way to do things is to take a minus b, absolute value, less than or equal to some threshold. A minus b could overflow, okay? I know that. This is a simplified thing. If you really want code that doesn't overflow, you have to write a difference function that does it right. I have one in my library. That's fine. But if I go into that, that's another talk. But it's doable. It's just not something I can do in 5 minutes. So let's suppose it's okay. So we're tempted to do something like absolute of a minus b, less than or equal to some threshold. Now, let's look at the threshold first. When I talk to engineers, they tell me 10 to the minus 6. That's the number. So it's what I use. But I'm not an engineer. So maybe engineers are right. I'm a computer scientist. But the easy way, I think, is to use a generic variable. So a template variable, that's kind of neat. Template variables are fun. We're almost done. Because you can express them based on type. So it could be something like template, class T, const expr, auto. Let's call that a threshold. I know it's a bad name for something so general, but we have the time that we have, which will be 10 to the minus 6 cast to a t. Something like that. Now, if you're worried, and rightfully so, that this could be an integer, I agree with you. Let's make sure it's a floating point. That way, if someone wants to have a threshold of int, it won't compile. Yes?
Why don't you get the next possible floating point number and compare the
This is cool, because if I do that, I'm not going to get anything useful, because I want to compare two values such that they're close enough for my needs. And if I get the epsilon, they'll never be close enough, because they're identical. So it depends on your tolerance to errors. So you see, when you're observing something on the microscope, you're going to have an error. So you have to decide at what point it's close enough for your needs. This is the engineer thing, I'm told, because I'm not an engineer. But if you put the epsilon, since it's the smallest thing you can have in between two values, there will never be any values that are not equal that are close enough. So you're not going to get anywhere with that. Is that okay? Now, and there's another thing we have to check, because time is flying. I'm going to add type trace there, because we're going to want to decide what T we're going to use there. Now, if you look at the comparison with the floating points that we have, if I want to pick a T, there's two types there. There's A and there's B. That's kind of annoying. So should I take the type of A or the type of B? That's a profound question. But it has an answer. You know what we do when we want to know what is the kind of common type of A and B? What is the type one would promote to? Like you have int and short. Short will grow to int, you know? You have int and float. The int would be cast to a float. How do we do that? You know ternary operator, like question mark, colon? When you have a condition and two values there has to be a common type between them, and the promotion gets done automatically from one to the other unless it's ambiguous. And we have a trait called common type T that does that in the standard that exactly does that. It takes a T and a U, puts them both in some kind of ternary, with supposing that they exist, we're doing tricks with this, and gives you the type of the expression. So the type that we have, the common type, is going to be common type T, is going to be what is common between the type of A and the type of B. Now, the type of A is this, and the type of B is this. I'm cutting corners a bit because they could be references and stuff, but let's keep it simple. I'm taking by value. So if I have float and double, it's going to be double. Cool. If I double and double, it's going to be double still, and so on and so forth. So I'm going to take the threshold on that type. Threshold of that type. That's going to be my error tolerance in this case. I still have a bug. Do you see my bug? I have a bug on line 19. Apart from the overflow of my A minus B that could happen. What's the other bug? Yeah?
Yeah, I think you missed a template.
Where?
In the equal operator. You took a temperature without specifying.
Okay, keep that one. I'm going to get back, but this one is okay. I'm going to tell you why. But it's cool that you're asking the question. We're getting there in a second. The bug that I have in this case is that ABS is a C function, so it's not context per. Oh, we're going to have to write our own. It's not difficult, mind you, but there's a trick. I'm going to write one that will work in our cases, but when you're doing numeric stuff, you have to be careful. It's filled with trouble. So const expert T absolute T val return val less than 0, darn minus val, otherwise val. Now this is almost okay. You have to know one thing, it's going to work, okay? But you have to know one thing there, there's undefined behavior in one value there. Which one? Because you're not allowed undefined behavior in const expert functions.
Minimal.
Exactly, a minimal value of t. So the min of t, for integers indeed, you cannot represent it in the the reference system you're trying to use. So if you pass, in this case, for an int like int min, you're going to get in trouble. It's undefined behavior, the compiler could complain. I'm not going to do that. It's a simple example. Is that okay? Cool. So I can replace my absolute from C with this thing. Now remember, there's still this A minus B is mean. But let's keep it this way for the simple example that we're doing. As I said, a difference function would be better. Which I should make a talk out of at some point, but I don't know if it's an hour-long thing. Now that we have this, we're going to get to your question, my friend. My friend was saying, you forgot a template somewhere, I think, because I saw you write that operator equal, and you're not saying what kind of temperature you're comparing to. Well, in this thing, if you're just saying temperature in the temperature of R, you're talking about temperature of R. Now, if you're saying, how are you going to compare a Celsius with a Fahrenheit in this case, that's so cool. Thank you for the question. So the thing is, there's no such function. There's no function in my code for equal between temperature of some type and temperature of some other type. But I don't need one because there's an inference system in C++. The inference engine will see, okay, you're trying to compare kelvins with Fahrenheit. I don't see how to do that, but I can take your argument and convert it into the type of the other one, and then I can do the comparison. It will kick in and do it on its own. And since it's all context per stuff that does very minor work, I couldn't do it better by hand. It's just awesome. It's just going to work. Is that okay? So we could check with our static assert that the code is okay. And my friends, it is. No, it's not. Damn, I forgot something, but it's simple. It's complaining. It's complaining that it can do both conversions because it's generating the conversions for me. That's evil. It's saying, okay, I have two conversions there, and for equal, and both are similar. So I'm not gonna have a choice. It used to work, but we're gonna fix it. Don't worry about that. It's saying I could do both conversions, could convert A to B, B to A, because C++20 rewrites stuff for me. So you're right, you were right, my friend. With C++20, I have to do it. I use not to. But we can do this. There we go. Will it work now? It's still, it's saying that my values are not equal. That's interesting. Did I make a mistake there? Is it true that 41 Fahrenheit is not equal to 5 Celsius?
Oh, it's the dot value.
The dot value. Okay, cool. So what am I missing? The value should be okay, shouldn't it? You're right. Or I could make it simpler and convert this equals to a temperature of R of the other. And not worry about that. That's even better. That's cooler. When you're doing live coding, you get what you deserve. Cool, this works now. So we have working code. It's kind of neat, okay? And just before we stop, because we're getting close, I'm going to get your question. Just so we can compare negative values, just know, because now if I try to do minus 41, the literal is still 41. It will complain that the temperature resulting has no minus operator, just to make sure that you can write correct code. You could add other stuff, of course, but temperature of R operator minus like this, just so I can sleep soundly tonight. Return a temperature. I said R, not T. Return a temperature with the negative of my value like this, and then I'll sleep better. So if we want to check it out to make sure it works, let's hope it does. If we're putting minus 41 in this case and converting, what is minus 41 Fahrenheit? I don't know in Celsius, we'll see. Well, it's pretty close to one another, so we're kind of there. That was it. The point, because normally we'd have a slide with the points, whatever we're talking about. I prefer the type system to leverage the tough work and the dangerous stuff for me, because I make mistakes. I'm human. I'm often tired. I have kids. I have a number of cats and 2 jobs. So I get tired and I make mistakes. I'm sure you don't, but I do. So making sure that the type system does the dirty work for me, type system doesn't get tired, it does the right thing at the proper time. So doing this sort of stuff makes it I can sleep soundly even when I'm doing critical stuff. These things, the user-defined literals, the context per work, static assert, they're safety features of C++. Well used, well prepared, they help you sleep better, and they help keep people safe. So I'm hoping this made you enjoy them. And I thank you for coming on such a short notice, since this talk didn't exist 4 hours ago. Thank you so much. If there's any questions, my friend, I'm going to repeat the question, is saying, right now, it's not production code, because you're accepting values that are below absolute zero. No? But maybe, in theory, you might want to play with it, because there's the physical side of things, there's the conceptual side of things, where you could go below and then come back or something. So I don't know. Now, I'm not a physician or a physicist, so I would have to think with the experts of the domain where the validation should be. I would definitely be running unit tests. I can tell you that much. And if I think it's important that the class prevents such manipulations, then I would build in stuff in it. But before doing that, I would explore the situation, because in theoretical physics, maybe there are cases where you want to suppose temperature that is below that even, because it comes back at some point later, because you're doing like complex numbers or something. So before doing something, I would consult.
Do you have a general suggestion of where you draw the line between what should be like the conceptual preconditions? Like, I'll never really have like a temperature like this in production versus actually enforcing it via the code. So might have some runtime.
Yeah. So the question is, where do you draw the line where the tests should go and what you should accept or not? When I'm an expert domain, I have a good answer for this. I'm not an expert domain in physics, so I'd be hard-pressed. I'm humble. I would consult for something like that. I'm really honest with this, because it's not my type. I like the coding side of it. But what do they do with this afterwards? Ugh, it's a bit strange for me. There was a hand in back. Yeah.
So there's potentially a design for a temperature class that is not templated, holds the neutral value, and then you can sort of convert to whatever specific temperature.
With an explicit function, you're saying?
Yeah.
We could do that. We could do that with doubles too.
Yeah. So like, can you compare sort of what pros and cons for this templated
Okay.
type versus just
Okay. So my friend there is saying, could you do a non-templated version of this really and add like manual functions like 2 Celsius or something within the function? If you do that, you're going to have a bigger temperature class because you're going to have to keep 2 values in there at least, the actual value you're computing and the reference system that you're going to represent within the thing by an enum or something like that. So each of your temperatures is going to be a bit bigger. Otherwise, it won't be safe. It's going to be like a double. You're going to have to let the user remember what the type is.
So in this case, you could have the neutral. Your neutral system is sort of opaque,
Mm-hmm.
and then you have 3 functions that can convert out of that neutral system 2 Celsius, 2 Fahrenheit, 2 Kelvin.
Or you just want to maintain a Celsius and then project into some other space? You could do that too. But then it amounts to doubles really because you don't get the protection of the type system unless you remember that you're always working with standard units. But then I wouldn't name that class temperature, I would name it Celsius.